So our topic today is titration. We prepared a short tutorial for you, give you some tips and some pointers so that you can successfully standardize the sodium hydroxide you will use in the second part of your experiment. First of all, let's look at our setup and our tools. So working left to right, the first thing you notice is your hot plate. And of course you see that it has a beaker of water on it. Now this is DI water and it's being warmed up. The first thing you need to do when you get into lab is make sure that your hot plate does have a beaker and the water is warming. The water should be not too hot to put your finger in, but definitely warm to the touch. Warm water dissolves KHP more readily than cold water, and the warming of the water drives off residual gases, including carbon dioxide, that will affect the titration by creating carbonic acid. So next in line in the back you see a liquid waste beaker, and then there's a little piece of paper between it and your Erlenmeyer flask. That's called a burette reading card. We'll explain more about that in a minute. Next to that on the right, you see your phenolphthalein indicator. Then you see your burette in its burette stand and its burette clamp. Below that is a little card we call a titration buddy. We'll explain more about that in a minute too. And then of course next to that is your bottle of deionized water. You'll need this several times during your operation. So this is a titration buddy. A lot of the things in titration have to do with being able to recognize contrasts at very low concentrations. Your endpoint is a very faint pink. Setting your Erlenmeyer on your titration buddy helps you see the endpoint. This is another place where contrast is very important. It's a burette reading card. Put it behind the burette and it will help you find your actual lines. And don't forget your indicator. Without your indicator, you'll never find your endpoint. Pay careful attention to this next slide. A burette reads from the top to the bottom from 0 to 50. We usually start at 0. We zero the burette. But you don't have to start at 0. You just have to know exactly where you did start. And you also have to make sure that there's enough titrant in your burette to finish the titration. One more tip. Label your flask. Oftentimes when you do titrations, you'll do 5 or more at a time, and you'll just make them all up at once, and it becomes necessary to do this. It's an easy way to avoid confusion. It's just a good habit to get in. As a general rule, you should be labeling most all of your glassware. It's especially important when you're talking about titration flasks. Label the flask, add the mass. Now we'll prepare titrate. So here's that warm water. You see obviously that there's handling it with just her glove. Notice she's rolling the flask around. That way she washes down the sides, and any KHP that might have gotten stuck on the sides will be washed into the mix. That goes back on the hot plate. Swirl this a bit. It's not going to dissolve all at once. Don't worry about it. It'll dissolve soon enough. Now she's going to raise up her burette so she can prepare it. We're going to show you that clamp here in a minute again. We can't show you the top and the bottom at once, so you'll have to use your imagination. So Heather placed her waste beaker under the burette, and you see how the clamp works. That's what you need to do. So now we have a waste beaker in place, and we're going to check the 0 on our burette. Remember, the reading has to be between the 0 mark and the 50 mark. You can't be above 0 or below 50 when you do this. So you see she's draining down the titrant down to the 0 mark. In a moment she'll stop and assess it. This is where you use the reading card. It's important to get your starting number just right. So we'll drain a little bit more. And she likes her number. So now we'll raise up the burette, remember keeping it in the clamp. Remove the waste beaker. Take the sample. Notice even more has dissolved now. It takes a few minutes. Then we're going to add the drops of phenolphthalein. Don't forget the indicator. 2, 3. 3 is more than enough. Position everything carefully. Another swirl or two. Note, from our vantage point, we can't see any of the particles undissolved at this time. And now ready to go. Before we proceed, let's discuss the subject of accessibility. The top of a burette is well over 6 feet in the air. If you're shorter, you're going to have trouble reading it. Keep in mind, you need to be able to see that burette level eye. So you can take it down to read it, but if you'd rather, we have some step stools that we can share. So now we're ready to begin the actual titration. So follow along as Heather does this job. So we're starting out looking at our burette. As you remember, it's all full. You can see that Heather's running a rather heavy stream. And notice that as the titrant hits the sample, ink does form. But then when you stop adding titrant, the pink goes away. Now, taking a look at the measuring end of the burette with our card, you'll see that we've added 7 milliliters of titrant here. So now we'll add more. Again, a rather quick stream. As you mix the system, it reacts and spreads out, and everything is neutralized. But you did have some hang time there, so let's take another look. Now let's make sure you understand what I mean by the term hang time. Hang time is how long the pink lingers after you stop adding more titrant. You'll notice the hang time is getting to be greater now. So in a steady stream, Heather is adding it more slowly. She's just using a stream of drops. But she continues to mix. She's slowed down even more now. Allowing the drops to come discrete and singly. Note the hang time gets longer and longer. Now Heather's going to show you a couple of very special tricks. First of all, she's going to just carefully, really carefully form a single drop. See that? One drop. That kind of control is important. But now she's going to do something a little different. She's going to make half a drop. She lets a drop part way out of the burette, and then she squirts it. That is the smallest you can practically add at a time, half a drop. Let this settle down for a moment. Heather's going to continue to work back and forth between single drops and half drops until the hang time becomes so long that it indicates that we're nearly to the actual endpoint. See there. Now it's time for some cleanup. Wash the tip. And then wash the sides. Make sure nothing's been splashed up onto your Erlenmeyer flask. Make sure there's no clinging solid. There's no drops of titrant. We're really close to our endpoint. Half a drop. Heather's going to wipe off the outside for clarity. Now let's finish. Wash the tip. And we have the faintest of pinks. At this point, take a full reading. Make sure you get all 4 significant figures. You can read 4 significant figures with your burette. Get them all. 3 definite figures and an estimate. And remember, we're talking about milliliters here. And there you go. 1 more drop after she measured her final amount did the trick. Now Heather is going to make another measurement at this point, and that number formally recorded. So she's going to hold it up here for you and let you take a good look at it. Now take a look at this. There's a proper endpoint, and there's an endpoint plus 2 more drops. Overshooting a tiny bit makes a huge difference. That's how sensitive it is. And now we're going to clean everything up. Run water down your sink and arrange your materials. You can pour the tiny bit of titrant you used in zeroing right down the sink, and you can follow it with the titrated sample. The rule is, if it's pink, it goes in the sink. Titration waste is not considered hazardous. And that's all.